Okay, question 23. Sketch the graph of the piecewise function fx equals to the x plus 1 and fx here equals to the 3. Okay, and first method using the graphical method. Okay, first here find the first function fx equals to the x plus 1. So you write down the fx here equals to the x plus 1, and the domain of this function x here less than 1. So here the graph of the linear function lf. And the second part of this piecewise function, constant function, fx here equals 3, when the domain of this function greater than or equals to 1. Okay, this one is a CF. Okay, first, before you sketch the graph of the linear function, fx here equals to the x plus 1. First here, find the y-intercept of the linear function. X here equal to 0, and find the value of y. So you substitute the 0 here into the function, and the value of y or value of x here equals to the 1. Yeah. So y-intercept of this function at the 0, 1. And second, find the x-intercept of the function. You let y here equal to 0, and find the value of x. 0 equals to the x plus 1, and the value of x here equals to the negative 1, and x-intercept at the negative 1, 0. Yeah. And you draw the graph of the linear function. Okay, first y-intercept of the function at 0, 1, and the x-intercept of this function at negative 1, 0. Yeah. So you draw the graph of a linear function, and domain of this function x here less than 1. Okay, so domain of this linear function, the value of x here less than 1, and find the point when x here equal to 0. So the value of y here equals to 1. So at the point 0, 1, here you put the empty circle. Yeah, empty circle. Empty circle at the 0, 1, meaning that the point 0, 1 is not included in the function. This one is correction. Here is equals to the... Okay, correct. So this is a correction. Okay, so the value of x here equals to 1, so substitute 1 here into the function, and here equals the value of y here equals 2. Okay, 1, 2. So here the point at 1, 2, you put the empty circle. X here equals to 1, and the value of y here equals 2. Yeah. Okay, so this linear function only defined when the value of x here less than 1. Okay, so this graph only defined or exists between negative infinity and x equals to 1. Okay, so this part of the function you can solve. Okay, and the second function, okay, second function, the graph of the constant function. You just draw the horizontal line. Okay, and the first one, x here greater than or equals to 1. Okay, so find the point and x here equals to 1, so f1 here equals 3. Yeah, this function equals to at 1, 3. Okay, so this point at the 1, 3, and here you put the then circle at the 1, 3. Okay, greater than or equals. And graph of the constant function, you just draw the horizontal line between negative to the positive infinity. Okay, start horizontal line. Okay, and the point here at the 1, 3. So this one is fx equals 3, and the value of y here equals 3. So first value here, x here equals to 1. So here you put the then circle. Okay, and then circle at the 1, 3 mean that's point 1, 3 is included. Okay, okay, and this graph of a constant function defined between 1 to the positive infinity. Okay, 1, 2, 3, 4 to the positive infinity, and this part of the function you can solve. Okay, and then you combine graph of the linear and the graph of the constant function. Okay, so you combine the graph of the linear function and the graph of the constant function. So graph of the linear function here defined between negative infinity and x equals to 1. And here you put the empty circle at the 1, 2. And the second function, graph of the constant, you just draw the horizontal line between 1 to the positive infinity. Okay, and find the left-hand limits of a function. Okay, so find the left-hand limit of a function. Limit as x here approaches 1 from the left of fx. Okay, so you find the left-hand limit of function. So x here approaching 1 from the left of the function. 0.9, 0.99, and 0.999. Okay, and it checks the y values. So y values here equals 2. Okay, and second, find the right-hand limit of the function. Limit of fx as x here approaches 1 from the right of the function. So start from here. And graph of x here approaching 1 from the right of the function. And check the y values on the y-axis. And the value of y here equals 3. So right-hand limit equals 3. Okay, and you compare the limit, left-hand limit of function. So limit of fx as x approaches 1 from the left of function here equals 2. And the limit of fx as x approaches 1 from the right of the function equals 3. If you compare the left-hand limit and the right-hand limit of the function, left-hand limit and the right-hand limit are not the same, not equals, because it's approaching the difference value from the left and from the both sides of the function. From the left here equals 2 and from the right here equals 3. Okay, and the conclusion, limit of fx here does not exist. D and E. Okay, and final answer. So final answer, fx not continuous at x equals to 1.